Introduction to Gravity. Gravity. It's a force we experience every day, but do we really understand it? Whether it's the reason why we stay on the ground or the force that keeps planets in orbit around the sun, gravity shapes the universe as we know it. But there's more to gravity than just what we feel here on Earth. Today, we'll explore what gravity is, how it works, and the theories that try to explain it. But here's a twist. Did you know that the gravity we feel on Earth is just one part of the story? As we dive deeper, you'll see how gravity changes everything, from falling apples to bending light around stars. Classical gravity. Let's start with Isaac Newton. In the 17th century, Newton revolutionized our understanding of gravity with a simple idea. Every object in the universe attracts every other object with a force. The bigger the object, the stronger its pull. That's why we don't float off into space. The Earth's mass pulls us down. Newton's law of universal gravitation boils down to this. The gravitational force between two objects depends on their masses and the distance between them. For example, the gravity between Earth and the Moon keeps the Moon orbiting us, just like how gravity keeps an apple falling to the ground. Simple enough, right? But Newton's theory, though groundbreaking, wasn't the final word on gravity. What if I told you that everything we thought we knew about gravity was redefined by one man? Get ready, because Einstein's take on gravity changed everything. General relativity. Fast forward to the 20th century, when Albert Einstein shook things up again with his theory of general relativity. Unlike Newton, Einstein didn't see gravity as a force pulling objects together. Instead, he described it as a warping of spacetime, the fabric that makes up the universe. Imagine a heavy ball sitting on a trampoline, causing the fabric to bend. That's what a massive object like the Earth does to spacetime, creating what we feel as gravity. This theory explains a lot of things that Newton's couldn't, like why light bends around stars or how time slows down near massive objects. Einstein's theory even predicts the existence of black holes, regions of space where gravity is so strong that nothing, not even light, can escape. And here's where it gets even weirder. What happens when gravity becomes so strong that not even light can escape? Let's dive into the mystery of black holes. Quantum gravity, the unsolved mystery. But Einstein's theory isn't perfect, especially when it comes to tiny particles or extreme conditions like black holes. This is where quantum gravity comes in. Scientists are still trying to figure out how gravity works on the smallest scales, where quantum mechanics, the science of the very small, takes over. There are theories like string theory and loop quantum gravity, but we don't have a complete answer yet. Quantum gravity could help us understand how the universe began or what happens inside black holes. It's one of the biggest unsolved puzzles in physics, and scientists are hard at work trying to crack it. Ever wonder how gravity really works inside a black hole? Or what happens when you mix it with quantum mechanics? It's one of the biggest mysteries in physics, and we're about to explore it. Let's compare the different theories. So how do these theories fit together? Well, Newton's theory works for everyday situations, like calculating the gravity between you and the Earth, or between the Earth and the Moon. But Einstein's theory of general relativity is necessary for extreme situations, like understanding black holes or the bending of light around massive objects. As for quantum gravity, it's the missing piece that scientists are still looking for to explain gravity on the tiniest of scales. Each of these theories solves part of the puzzle, but can they all come together to form a complete understanding of gravity? Let's find out. Effects of gravity. Let's break it down to how gravity affects us in real life. On Earth, it's what keeps everything grounded, from keeping water in our oceans to allowing us to walk and drive. But gravity changes dramatically in space. Astronauts aboard the International Space Station experience microgravity, which is why they float freely, even though they're still under the pull of Earth's gravity. Gravity is also behind one of the most visible natural phenomena we experience, the tides. The Moon's gravitational pull on Earth causes the rise and fall of the oceans, something we see twice a day, every day. We've seen how gravity works on Earth, but how does it change once you leave the planet? Let's find out how gravity in space works differently, and how astronauts actually float. Famous experiments demonstrating gravity. Now, how do we know all this? Over the centuries, scientists have conducted experiments that prove the laws of gravity. Take Galileo, for example. Legend has it he dropped two spheres of different masses from the Leaning Tower of Pisa to show they would fall at the same rate. Then there's Henry Cavendish, whose experiment in 1797 calculated the gravitational constant and even helped determine the mass of Earth. Think you know how gravity works? Wait until you hear about the simple experiments that changed everything, from Galileo's famous tower drop to Cavendish's calculations of Earth's mass. Interesting gravity phenomena. And gravity gets even more interesting. In the case of black holes, gravity is so strong that it warps time and space, creating a point of no return. Then there are gravitational waves, ripples in spacetime caused by massive objects like colliding black holes. These waves were first detected in 2015, confirming yet another part of Einstein's theory. And who could forget the sci-fi appeal of anti-gravity? While it doesn't exist in reality, the idea of floating without gravity has inspired countless films and books. But, as far as science knows, we're still bound by the laws of gravity. What about gravitational waves, ripples in space-time caused by massive collisions in the universe? And is anti-gravity really possible, or just science fiction? Let's dive deeper. Closing thoughts. So, from keeping our feet on the ground to shaping galaxies, gravity is one of the most important forces in the universe. While we understand a lot about how it works, thanks to Newton and Einstein, there's still plenty more to discover. Who knows, maybe the next big breakthrough will finally reveal the secrets of quantum gravity. The mystery isn't over yet. New discoveries about gravity are happening all the time, and we're closer than ever to unlocking the full picture.